What's good, math family? Today's video, we're going to look at simplifying radical expressions by adding, subtracting, multiplying, and dividing. In our last radicals video, family, I showed you guys how to skip rationalizing denominator. So let's say we had this problem, right? Typically, we'd break it down like this. Radical 4 times radical 3 all over radical 3. And when we do it like this, the trick I showed, we could just use the properties of fraction and cancel, and we would have radical 4, and we'll simplify it to just get an answer of 2. Now, what most of us do, let's pick up this step right here. So let's say we had 2 radical 3, and we have radical 3 on the bottom. So we'll rationalize it, and then what we'll have is 2 times 3 on top to get 6, all over 3 on bottom, which is still equal to 2. So this is just a trick to help you guys bypass it. When can we use this? I would say use it when you're able to cancel out factors in the numerator and denominator. So look at this, right? We have 4 radical 5 over what? Radical 4 times radical 5. Now, typically, once we simplify, we would have 4 radical 5 over 2 radical 5, and then we'll go and multiply top and bottom by radical 5. But with this method, right? Cancel out 4 divided by 2 just gives me an answer of 2. So this is what I mean, family, when we're able to skip rationalizing. Now, when we come with variables, same thing. And let's say if we put the entire fraction under the square root, right? It wouldn't make a difference once you do the work. So this is what I mean. So once we start breaking this down, right? In the top of our fraction, we're going to have 9 times 2 times x to the 5th divided by 2 times x to the 3rd. Now, once you look at this, family, these 2's both cancel. And once we follow the properties of exponents, this cancels out and x to the 5th turns to x squared. Now, all we're left with is radical 9x squared, which simplifies to just 3x. And if you're looking at the previous video I did, family, it's the first video linked under this video for you. All right, last problem. So same thing. Let's say we did the other way. So we have 4 times radical 5 all over radical 5, right? So we have 2 radical 5. So we rationalize now. Rationalize. So this turns into 2 times 5 all over 5. So we have 10 over 5, which is just equal to 2. Like I said, let's say we go back to this step right here. All right, so let's highlight this step. Radical 4 times radical 5 over radical 5. If we use properties of fractions, we're left with the square root of 4, which will simplify to 2. This quotient rule for radicals, guys, we can't do it with every problem, all right? So let's see if we could do it with these. So we start off, top stays the same. The bottom, we could turn it into radical 9 times radical 5x times x squared. All I did was split x to the 3rd. So 5x cancels out with 5x. We're left with negative 1 over what? Radical 9 times x squared. Both of these are square roots. So we have negative 1 over what? 3x. Second example now, right? Let's just cancel from the beginning. So I have 2 radical 20 all over radical 5. Now, you've seen what we've done earlier. We're going to do the same thing. So this turns into 2 times radical 4 times radical 5 all over radical 5. Those 2's cancel. 4 turns into 2. We multiply what's left over, and we get 4 as a final answer. Now, our last example, we're probably not going to be able to use this rule, family. So when we look at 84, and let's see. We could change this into the square root of 4 times the square root of 21 all over 2 radical 3. Now, once this comes out as 2, we could cancel those out. So I'm left with radical 21 over radical 3. I'm going to rationalize it now. And what I'm going to have is radical 63 over 3. Once I simplify this one step further, we get radical 9 times radical 7 all over 3. And this turns into 3 radical 7 over 3. And once we cancel our 3's, our final answer is radical 7. So this problem, I probably wouldn't use our trick because we may get the wrong answer. We're now on to adding and subtracting radical expressions. So family, right, have to have the same exact radical for us to add. So we're going to start off with this, right? So this turns into what? 25 times radical 3. Perfect square comes out. We're left with radical 243 minus 5 radical 3. Now, anytime we have these type of problems, let's see if we could divide this radical by 3, right? Because we have to have the same number on the radical to add or subtract. So I divide by 3, and I understand that this is 81 times 3 minus 5 radical 3. So now I simplify, right? This turns into 9 radical 3 minus 5 radical 3. Final answer is 4 radical 3. Okay? Second example. Can't do anything more to it. Can't do anything more to that. Let's focus on radical 20. So this is 4 times radical 5. This turns into 2 radical 5. We bring everything else down. My bad, family. So you know at this step, this is not a like radical to these two. They're not exactly the same because it has an x under it. So we add the coefficients for like radicals. That gives me 5 radical 5. And we bring the other one over, meaning we just add it at the end. So my final answer would be 5 radical 5 plus radical 5x. Now we go to a longer problem. And I want to tell you all, right? Start off with what you know. So I know 175. I know that's probably have to do 25 times something, just like this one would be 9 times something. So let's start off with here. 5 radical 7 stays the same, right? We're going to keep this the same for now. And this turns into what? 25 times radical 7 minus radical 9 times radical 7. So we notice now what? Perfect square, perfect square. So this is 3 radical 7 at the end. This is 5 radical 7 right here. And we have another 5 radical 7. So family, when I look at this, guess what I'm going to divide that radical by? 7, okay? So 448 divided by 7 gives me 64. So I know this is radical 64 times radical 7. So this turns into 8 radical 7, right? Now with this step, everything has the same radical. We just need to add and subtract the numbers in front. So 5 plus 5 gives me 10, plus 8 gives me 18. 18 minus 3 is going to give me 15 radical 7. Last part of this video, family, really hope you enjoyed. We're dealing with multiplying and distributing radicals, okay? So we could distribute this radical to get radical 24 plus radical 36, and then we break it down. But fam, that's too much. Simplify this to its square root. Radical 6 times 2 is just 2 radical 6. Radical 6 times radical 6 is just a number without the radical. That's our answer. Let's keep it like that. Least amount of steps. Now, problem 2, box method, right? You guys know I love the box method. So I have 8 negative radical 2 here, 8 negative radical 2 here. All it's saying is we're going to take this expression, write it twice, distribute / FOIL. 64. 8 times negative radical 2 is negative 8 radical 2. 8 times negative radical 2 is negative 8 radical 2 again. And radical 2 times radical 2 is just positive 2. Like terms right there. We get 66. Negative 8 and negative 8 is going to give me negative 16 radical 2. Final answer. Now we get over here to distributing again, right? So once we distribute, we have negative 4x times radical 3x. Distribute again, we're going to have, oops, not plus, I'm sorry, minus x times radical 6x squared. Now what happens is x comes out, and once we rewrite this, we're going to have negative 4x times radical 3x minus x squared times radical 6. So this will be our final answer. And now we're going to go over to our last few examples of this video. We're going to finish this video off with multiplying radicals with coefficients and variables. And just remember that when we multiply, family, coefficient with coefficient, right? So we have 14, and then 30 times 6 gives me 180. When we multiply exponents with the same base, we add. So we get x to the 8th. Now I want to break this radical down. And if I'm not mistaken, we could break 180 down with 36. So we have 14 times 36 times 5 times x to the 8th. All right, this perfect square comes out. We have 14 times 6 times, and x to the 8th comes out at x to the 4th. And then radical 5 stays under. So once we multiply 14 and 6, we get 84 x to the 4th times radical 5. So anytime you multiply or distribute with radicals, you always have to double check to see if you could break down the radical, okay? All right, next problem, same thing. 3 times 2 gives me 6. 7 and 14, Lord. I think that's 98. Yep, we get 98 x to the 3rd. Once we try to break this radical down, we have 49 times 2 times x to the 3rd. So right here, 7's going to come out. We have x squared, which is equal to x. We got 1 left over under the radical. So let's simplify. So 6 times 7 gives me 42. X squared came out as x. And under the radical, we have 2x left over. So when we're talking about simplifying radical expressions by adding, subtracting, multiplying, or dividing, family, we really hope this video was helpful and cleared up any questions you've had. If this video was helpful, just smash the like button for us. Comment down below if you have questions on this video, or if you want to see similar videos on our channel in the future. Thank you guys so much for watching Algebra 1 with Mr. Peters.